Hi, Assalamualaikum. Greeting to Dr. Musli and TS Mustafa Kamil. My name is Indah Eliana bin Sajiran and I'm one of the group member of the group 1. So, first of all, thank you for giving us the opportunities to do our project in subject railway modeling and design. So, for this subject, we are given the theme sustainable railway vehicle design and development. So, before we further our presentations, let me introduce my group mate in another slide. So, for this project, we are divided into 5 group members, namely Azri Shafiq, Aiman Akil, Faiz Hafifi, Irfan Helmi, and me, Intan Eliana. So next, I'm going to the introduction. So our innovations designs called railway magnetic coupler. So these ideas of innovation designs to the existing railway coupling because of the certain shortcomings that can be taken into the account for the improvement. This is because the recent coupler design needs schedule maintenance such as the grease applications, and mechanical coupler can be susceptible to the damage due to the shock and vibration, leading to the reduced performance. But the magnetic coupler can be coupled and uncoupled much faster than the mechanical coupler, so this is can save the time and improve the efficiency. And also the magnetic coupler can focus on the beneficial as the environmental benefits. This is because the magnetic couplers doesn't need require any lubricant, so that can help to reduce the pollution. And this innovation design start with the hand sketching and we draw using the Tinkercad software. So the Tinkercad software ensure the dimension are accurate and the design are reliable. So we are using also the in addition we are using the SolidWorks software and also use to design the train to be combined with the design of the magnetic coupler that has been designed using the Tinkercad software.
Assalamualaikum and good days. My name is Ifan Helmi and today I will be presenting to you about the literature review of our railway modeling project. The main function of railway couplers in which is our main object of this modeling project. The main function of railway couplers is to hold the cars together from the first tug of the engine as it force overcomes the inertia of each car to the end of the train. Couplers requires extraordinary strength and flexibility to maintain its hold over hills and dips, along curves and over the rough tracks. Since the invention of the train is mid of 19th centuries, there are several types of couplers that have been designed and developed during this era. There are several types of there are several types of railway there are several types of railway couplers that have been developed and designed have been used, such as the screw couplers, link and pin couplers, canonical couplers, semi-permanent couplers, and scaffold couplers. All of these couplers have been developed and have been having its own advantages and disadvantages. In reviewing several types of railway couplings used in the railway industries, there are two major concerns, which is the safety and maintenance issues. Manually operated couplers such as screw couplers and pin and link couplers may raise the issues of safety, as the lever carrying the coupling was may expose to the head injuries or getting hit by moving trains. Furthermore, the manual operation of link and pin couplers may expose the workers into risk of head injuries. Before the implementation of chain couplers in 1902, the number of hand injuries related accidents was 11,000 cases. When the link and pin coupler was in use, the number of cases accident was dropped into 2,000 in year 1902. In the case of maintenance issues, the couplers with moving parts such as knuckle couplers, jenny couplers requires frequent lubrication and protection from rust. Although the jenny couplers have been proven um, sufficient to and have higher capabilities to hold and pull the higher loads the higher amount of loads, hence resulting in more effort and costly maintenance works. Besides, without a proper use of coupling or heat treatment of the railway couplings may result into railway coupling parts cracking, defects, failure or breaking of couplers due to excessive flows and tensile stress. In order to resolve the issues regarding the railway couplers, safety operation and reduction maintenance issues, the idea of using magnetic powered coupler come out in this modeling project. Magnetic coupler uses a magnetic attraction force to hold the cars together. High amount of current from uninterrupted power supply is used to generate electromagnetic flux via a magnetic coil on each coupler devices. In terms of flexibility, each end of the magnetic coupler is equipped with a shock absorber, capable in absorbing forces during coupling operation and articulation mechanism to allow couplers to move freely. Besides, the introduction of railway magnetic coupler requires less maintenance as this type of magnetically powered coupler has less moving parts to be maintained or lubricated. The idea of using magnetically powered coupler is not being studied progressively, as these ideas are still new and had never been tested or applied in the railway industry. However, the magnetic coupling has been studied, practically used and developed as wireless charging system as the alternative power supply for overhead wires via pantograph and third rail by Jiang Yi et al. And other group of Chinese researchers. However, the application does not focus on the function of couplers in holding two cars together, but as wireless charging technology, which does not fulfill the objective of this railway modeling project. The concept operation of these railway electromagnetic couplers is the same as the operation of electromagnetically operated crane. In order to find the certain amount of electromagnetic flux or the pulse strength in Weber, this formula from the equation one can be used, in which this equation one had been developed from the concept of Newton um, Newton gravitational attraction law, in which the force of attraction is directly proportional between the uh, directly proportional of the amount of multiples the amount of product between two pole strength, in which the phi1 and phi2 over the square distance of between them, in which the distance between the sources and the object that want to be attracted. To find the amount of current that have been needed to generate a certain amount of um, magnetic flux, equation 2 can be used, in which the phi is equal to half multiplied by mu naught n I a, in which the mu naught is the permeability of free space, n is number of turns of the solenoid, I is the current supply, and A is the area of solenoid.
Thank you to my previous group member for explaining about the previous slide. So now I am going to explain more about our group's methodology. So our group started with three design proposals, which are magnetic train coupler, rearrangement of train seat at train station, and also the redesign of KTM ADNS coaches. So the flow will be continued with the design proposal evaluation, which only one proposal will be selected based on two criteria, which are first the impact of our design proposal towards the industry, and also the limitation of design implementation, because design process will involve technical skills, and since our group member have average technical skill, the proposal with the simplest design will be selected. As one design proposal has been selected or agreed, the proposal will be completed, and if it is not agreed, a new proposal will be suggested. So the design consideration and also the calculation will be carried out related to the topics, and we will proceed to the 3D modeling and also the simulations. So if the same process cannot be achieved, the proposal will be revised up until the correct design consideration and also the calculation can be determined. Next, I will explain more about our electromagnetic conceptual adaptation. So in our project, the concept of electromagnetic crane is considered as the crane utilizes the principle of electromagnetic to lift and move heavy object. So it consists of large electromagnetic, often in the form of large electromagnetic drum. So the Faraday's law of electromagnetic is applied when electromagnetic is switched or on or off. So when the current flow through the coil of the electromagnetic, magnetic field will be created, and this magnetic field will attract any ferromagnetic materials around it.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Aiman Mamakil bersama number matrix CN210020. Okay, I will present about design of train and magnetic coupler. Okay, the first picture is about design of combined train and magnetic coupler, and the second picture is this our design magnetic coupler in our project. As you can see, the book design is the book design we use only SolidWorks and Tinkercad. I will explain about development of magnetic train coupler. First, we have three components. First component is soft iron plate. Soft iron plate has high reactivity and low coercive force can retain the magnetization, although the magnetizing field is reduced to zero and enable a small force are needed to demagnetize the magnet. Okay, second component is damping system. The damping system works to attenuate torsional vibration, dampen oscillation, and mitigate resonance, resulting in smooth operation, minimize stress on component, reduce noise level, and enhance system durability. Uh, that component is uninterrupted power supply, with the integration of UPS system. The trend electromagnetic coupling to overcome power fluctuation, voltage and interruption that may occur during operation.
Okay, now I will present about the result and discussion. The magnetic coupler consists of two main components, which is a nose coupler and south coupler. The nose coupler is located on the train car, while the south coupler is on the adjoint car. These couplers have magnetic that are aligned to attract and connect with each other. Next is benefit of magnetic coupler. The first benefit is ability to provide an more flexible connection between train car. Next is improved safety features, and last but not least, the benefit is contribute to a more comfortable ride for passenger. Next is for dimension of magnetic coupler. Magnetic coupler have a length is 9.91 feet, while width is 9.6 feet and height 1.84 feet. For the damper, the length is 4.4 feet, height is 1.13 feet, and the diameter 0.43. For the spring damper, length 1.47 feet, height 0.6 feet, and diameter 0.6. Next, dimension for mounting. The leg is 0.65 feet, width is 9.6 feet, and height 1.7 feet. And the last one is soft iron plate. The length 0.33 feet, width is 2.57 feet, and the height is 1.09 feet.
So for the conclusion, what I can conclude is the magnetic coupler have their own advantages, and also they have a factor that need to be considered during the designing it. So for the advantages such as the quicker coupling, less wear and tear, increased safety, smoother ride, and environmental benefit when such as what I already told at the introduction. No lubricant, no we can reduce the pollution. And during design the magnetic coupler, they have a factor that need to be considered, such as strong magnetic field for high speed stability, minimize wear and tear for longevity, longevity and derailment prevention for the action safety and compatibility with diverse train types and network. So as we know, the magnetic coupler design is a quite difficult task, but the potential reward are enormous. The magnetic coupler provide a variety benefit over the conventional mechanical couple, and as the technology advances, train operator will find them to be more attractive coupler. So that's all for our group presentation for the railway magnetic coupler. So thank you for listening and thank you so much.